Alright folks, welcome back. In this video we're going to talk about how to graph parabolas. We talked about how to graph lines, now we're going to work on parabolas, which are, as we know, slightly different. So, just a reminder, something that we need to know when we're talking about graphing parabolas is the standard form of a quadratic. Remember, a quadratic looks like this. It's got an x squared term in it, right? A variable squared. So the standard form is y equals ax squared plus bx plus c. A number times x squared plus a number times x plus a number times c. Now, it's possible that some of these terms don't appear in an equation. For example, if we had something like this, where the bx weren't there and it were just a number times x squared plus another number, that would still be a quadratic. It was just missing the bx term. Now in that case, the b is actually a 0, okay? Whenever a term is missing, the variable or the number in front, the coefficient of the variable, is actually 0. So if I have ax squared plus bx and there's no c, and there's no number floating around over here by itself, then that number is 0, okay? So just because a term is missing, right, you don't see it in the standard form, quote unquote, that doesn't mean that it doesn't exist. It's just a 0 is the coefficient. So just keep that in the back of your head. Alright, so now that we know the standard form, let's take a look at an example. So here we have y equals x squared plus 4x plus 4. Now the first thing that we want to do always is identify our a, our b, and our c. Okay, so our a is whatever the coefficient of the x squared term is. So whatever number is in front of this x squared. Now we know when the number doesn't really appear, it's just a 1, right? So a is 1. B is whatever number is the coefficient of the x, so that's going to be 4. And we see that c is 4 as well. It's the number floating around by itself. So we've identified our a, our b, and our c. Now what? Well, remember, the parabola looks something like this, right? So here are our axes, and in green here, what I'll do is I'll just draw a parabola. So our parabola looks like this. It either faces up or it faces down, right? It's this kind of U shape or this cup shape that's either up or down, okay? Now, with the parabola, there's a couple things to notice, right? How do we decide, first of all, whether it faces up or faces down, and what points are actually important? Well, I've said it before and I'll say it again. The most important point on the parabola is this guy here, the one at the very top if it's facing down, or the very bottom if it's facing up. Those points, once again, are called our vertex, or our vertices if there are more than one. Our vertex is the most important point of the parabola. So if we are graphing a parabola, the first thing we need to find is the vertex. So let's keep that in our head. The vertex is the most important point of the parabola, and that's what we need to find first. Later on, we'll identify how we decide if it opens up or opens down. Okay, so looking at the vertex, we need to find it. Alright, so looking at our equation now, x squared plus 4x plus 4, how do we find the vertex? Well, remember, the vertex is just a point. It's a special point, but it's a point nonetheless. So our equation was, once again, y equals x squared plus 4x plus 4. We have a is equal to 1, b is equal to 4, and c is equal to 4 as well. The vertex, how do we find it? The vertex is given to us by the following point, h, comma, k. H is just an x value, a specific x value, and k is just the y value that we get when we plug in our x value of h. So how do we find these h and k values? Well, h is actually given to us with a very specific formula that's given to us from the standard form. That's why we need to know the standard form. H is equal to the negative b over 2a. So negative, whatever the b value is, all divided by 2 times a. Now this is why we picked out our a, b, and c at the very beginning. Looking at the standard form, we found our a was 1, our b was 4, and our c was 4. Now that we have that, we can plug that into our equation for h. H is given to us by negative b, so negative 4. All divided by 2 times a, which was 1. So negative 4 divided by 2 times 1 is negative 4 divided by 2, which is negative 2. So we have that h is negative 2. What does that mean? Well, remember, my vertex is h comma k. That means I have negative 2 comma k. I have half my vertex. Now I just need to find k. Now how do we find k? Well, remember, this is just a point. And the values inside of a point, the x and the y values inside of that point, are related to one another. Meaning when I plug in an x value, I get the y value that corresponds to it. So when I plug in my x value of -2, I should get k. So if I have y equals x squared plus 4x plus 4, as soon as I plug in -2 for x, -2 squared plus 4 times -2 plus 4. This is all equal to k. Because as soon as I plug in -2, what I'm finding is the corresponding y value. And the y value that corresponds to h is k. So k is equal to -2 squared plus 4 times -2 plus 4. So let's evaluate and find the value of k. So -2 times -2, or -2 squared, is positive 4. Plus 4 times -2 is a -8, plus another 4. So I've got 4 plus -8 plus another 4. 4 plus -8 is -4, plus another 4 is 0. So I have k is equal to 0. So what does this tell me? This tells me that my vertex is -2, 0. That is my vertex. This is the starting point for graphing any parabola. Find the vertex. Find the vertex, okay? Now that we have found our vertex, what do we do, right? That's the next important question. What do we do after we have found our vertex? Now remember, let's think about the graph. We know that our vertex is going to be over here at -2, 0. I'm going to graph it in green. -2, 0. That is our vertex. Now we didn't make a decision. Does our parabola go up or does it go down? Which one is it? We can actually figure that out very easily by looking at, once again, the standard form of our parabola. So x squared plus 4x plus 4. The a term is the important piece of this puzzle that tells us whether the parabola opens up or opens down. A is 1, specifically a positive 1. Since a is positive, we know that our parabola opens up because a is positive. If a were negative, let's say our equation were y equals -2x squared plus 4x plus 3, since a in this case is -2, that would mean that our parabola opens downward when a is negative. So when a is positive, we know our parabola opens upward. When a is negative, we know our parabola opens downward. I don't care what the other numbers are at all when I'm deciding if it opens up or opens down. All we care about is a. If a is positive, it opens up. If a is negative, it opens down. It's that simple. So we've established that it opens upward. We need to find 2 more points, one on either side of our parabola. One over here, let's say, and one over here. One on either side of the vertex in order to complete this graph. So, we have 1. We have 1. Let's build a table. So, x, y, we have -2, 0. That's my vertex. I need to find 2 more points, one on either side of my vertex, in order to graph this parabola. Meaning on either side, I want to find one with an x value that is less than our vertex and an x value that is greater than the x value of our vertex. So, if I have -2 as my vertex, the x value for my vertex, let's pick a number that's bigger than it. Hey, how about 0? 0 is bigger than -2, and that makes our lives really easy when we're plugging in, and we'll see that in a second. And then let's pick another one. Let's say something that's less than -2, so let's make our lives as simple as possible. Let's do -3, right? It's always better to work with small numbers. It makes our lives a lot easier. So let's plug in. So our y value, when x is 0, is equal to 0 squared plus 4 times 0 plus 4, right? So we pick values that are easy to work with, because when I plug in 0 into our equation, well, these guys go away. 0 squared is 0, 4 times 0 is 0, so this is equal to 4. So the y value of my x value when x is 0 is 4, so my point is 0, 4. So far I have my vertex, negative 2, 0, my first point, 0, 4, and now I need to find another point, and I'm using negative 3 as my x value. So I plug in negative 3. So negative 3 squared plus 4 times negative 3 plus 4, that's equal to, negative 3 squared is 9, plus 4 times negative 3 is negative 12, plus another 4. So 9 plus negative 12 is negative 3, plus 4 is 1. So my last point here is negative 3, 1. Now, we use all three of these points to graph our parabola, starting with the vertex, always starting with the vertex. So let's put our hash marks on here. So now that we have all of our hash marks, let's graph our points. So, negative 2, 0 is our vertex. Again, I'm going to put that in green. Negative 2, 0. The next point that we found, which was to the right of our vertex, is 0, 4. I'm going to put those in blue. 0, 4, so that's all the way up here on the y-axis. And the last point is negative 3, 1. So negative 3, 1. Now, it doesn't matter where these points actually are, as long as they're one's to the left and one's to the right, because what happens is, now that I have them, I connect the dots, and I know which direction it faces, so I can kind of approximate this curve here. And that right there is the graph of my parabola. This is the graph of y equals x squared plus 4x plus 4. So guys, this is how we graph parabolas. It works this way every single time. First you find the vertex, then you find two other points, and then you graph it. It works just like that, okay? So check back in for more examples. I'll see you next time.